Good afternoon. Within the program of international conferences organized by Campus do Mar, we are pleased to introduce you Dr. Antonello Sala. He's head of the Fishing Technology Unit of the Italian National Research Council in the Institute of Marine Sciences. He's as well a member of the ICES FAO Working Group on Fishing Technology and Fishing Behavior, and president of the National Commission Unitex Fishing Nets and Ropes. Dr. Sala is an expert in fishing gear technology and fuel saving, as well as efficiency and selectivity research focused on measurements of the engineering performance of the fishing gears at sea using underwater instrumentation. Dr. Sala?
Thank you. Before I start with my presentation, I would like to introduce this website where you can find all the information we collected during a project funded by the European Commission. We provided all the information to the Commission related to the energy use in fisheries. And also we found information on some initiative very interesting for fuel saving. So please take notes of this website, visit, and you can download all the paper we collected and also report and any divulgative manuscript that we found during this year. So my presentation is made of 3 parts. In the first part, we will see a project where we analyze the energy used by the fishing vessel. We analyzed, and we are still analyzing, some fishing vessel for measuring the energy during fishing, steaming condition, all the phases of their work. Then I will present another project. It's a project where we develop such process called energy audit, and where we measure all the where the energy is going during the phases of fishing. And finally, if I have time, I would like also to introduce the last part, where we tested some promising otterboard that we tested during an experiment for investigating if there is a potential for reducing the cost during fishing. So these are the main factors that affect the fishing industry. Those in the first line are influencing the revenue, and in the second part, influence the cost. So fuel actually influence the cost of fishing, and because there are restrictions related to the actual overfishing, and is impossible to fish more, the only possible solution to reduce the cost and improve the economic activity is reduce the fuel consumption. It's time to act, actually, because there is a deep crisis, and only those people that are more responsive to change can survive. So first of all, I would like to introduce this system that we developed in Ancona. We named that system Corfu because Cor stands for Coriolis, is a system for measuring the fuel consumption, and is based on the Coriolis principle. And there is a part where we installed the sensor on the engine for measuring the inlet and outlet flow of the consumption. And then there is a part where we record the data called a multi-channel recorder. And there is also a very simple GPS data logger where at the same time we measure the fuel consumption and the position and speed. So just very briefly, I will show you that during the first phase of the experiment, we installed this system on board two different vessels of two different pair trawler. In Adriatic, we have a vessel like this that they fish in trawl, towing one net, one trawl for catching anchovies. It's a pelagic fisheries. And the difference between these two vessels belonging to two different pairs is in the propeller design. One has a fixed propeller design, and the other is a controllable pitch propeller. So these are some pictures of the activity. And this is the mass flow sensor mounted on board one of the fishing vessels. So the flow enter and exit the other part. And and it measures the mass of the flow. This is the multi-channel recorder. So fishermen can see how much it consume the consumption during the activity. So at the beginning, there was also a behavioral effect on the fishermen. I will show you later during the presentation. This is the simple part is a GPS logger. Instrumentation must be simple on board, simple and rough because of the sea condition. So these are the sensor mounted on the inlet and outlet part. So the differences between the inlet and the outlet gives the consumption. This is just to show the dimension of the sensor. So this is the principle of the Coriolis. When there is no flow, there is no Coriolis effect, and then the flow in these two pipes is in phases. And when there is a flow, the differences in phases gives the consumption. This is the harbor of where I live. Is Ancona Harbor in the center of the Adriatic, and it gives is a picture showing the departure of the boat and the coming back. They have a one-day trip, so they go out in the morning and they enter in the afternoon, late in the afternoon. So this is the cost of Adriatic coast. This is Ancona. It's in the middle of Italy, and this is a typical cruise, fishing cruise. The color are proportional to the speed, so it's very easy to find the trawling. Before starting, we discretize the fishing cruise in different phases or different operation. So the fishing boat are searching the fish. Then when they find the school, there is a phase called pre-shooting, then shooting, trawling. They close together each other, and there is a recovery of the trawl, and then hauling phases. And one vessel take the catch on board. So these are the description of the phases. These are the main 5 operation. Just remember the acronym. So this is sailing, searching all together. This is shooting, trawling, hauling, and towing cable. The most important are these two: SSS, which is sailing during the fastest part of the cruise, and then trolling part. So we gave an acronym to the first boat. This is PB, stands for pelagic boat 1, and this is PB2, is the pelagic boat 2. And these are the speed, vessel speed, and this is fuel consumption. So it's in liter per hour. And as you can see, this is the phase of SSS, which stands for sailing, is the fastest part. They sail at 10 knots, 11 knots. And this is the most expensive part, which is actually the trolling. So these are table that show the fuel consumption and the speed, the mean speed and the mean fuel consumption of each boat. So the first usually sail at 10 knots, and the other more or less the same. And this is a fuel consumption. One is as 85, the other as 101. And during trolling, they tow the net at 4 knots, more or less the same. They are very similar in the troll dimension. And one has 129 and the other 133. So I just concentrate in these two phases here. And this is during steaming and searching operation. I just want to show you how big can be the saving, just reducing of half knot. Look at 10.5. Compared to 10, they can save more or less 12. The other is more expensive. And just reducing half knot, they can save 16%. So this is the difference between this speed and the correspondent speed less 0.5 knots. So this is an evaluation of the cost of the full system is around 9,000 euro. Now we go for the second part, is the energy audit. And here we studied where actually during the operation the speed is going. Energy audit is a systematic approach to evaluate the energy consumption. And is very well defined in all the phases, and we try to respect the references given by the Commission. So these are the phases. There is a preliminary investigation and inspection of the fishing vessel. Then there is usually an installation of the system on board. We go at sea with the fishermen in the sea trials during the commercial days. Then we have the post-processing data. We develop some indicator. I will show you just 2 indicators. And then we draw the energy profile, giving a energy class, like a washing machine, more or less. So these are the systems we installed on board during this experiment. We installed the fuel meter for the fuel consumption, the torque meter. It's very, very important for measuring the power delivered. And then we also tested meters for measuring the hydraulic and the electric power. We used the strain gauges for measuring the gear drag, and then also GPS for the speed and position. Yeah, we also give an indication to the fishermen about gear geometry, but it was not so necessary for the energy profile actually. And the system is all synchronized. All the systems are synchronized, so all the data are collected at the same time, and all the information can be related to each other. This was one of the first tests, but we found a big error in this system. It's based on acoustic principle. So this meter sent an acoustic signal into the pipe, and then it was possible to measure the fuel consumption without cutting the pipe where there is the flow. But the error was too high, so we just decided to not continue with these meters. And this is very precise system. It's a torque meter for measuring the power delivered. So it's actually the power that arrive at the propeller. We mount a strain gauge and also a system for measuring the revolution of the propeller. This is a system for measuring the hydraulic and the electric power. This is electric. This is for measuring the hydraulic power for any deck machinery. And we measure, as I said, the total gear drag by using this sensor, which is very, very easy to use for one-day trip without any installation. So these are the vessel. I gave an acronym, the length, and I just for an indication, length overall, the tonnage, and some other information. You can find all the information describing the vessel. I leave already the PDF, so you can have a look if you are interested. And then the analysis is based on these two indicators. One is the energy consumption, the total energy consumption. The other, the fuel consumption indicator. So these two will give a class to the vessel. Of course, bigger it is the fuel consumption, and worse is the profile. So these are some graphs that show you during the trawling phases. This is the total drag, and we related to the total drag all the other parameters like power delivered, fuel consumption, and this is the indicator of fuel consumption, and this is the energy indicator. So you can see there are two clusters. One for otterboard and demersal fisheries, and the other for the pelagic fisheries. It seems that the pelagic fisheries can be more expensive than the demersal. Of course, because of the dimension of the net and also the faster speed used by the boat. And these are graphs during the sailing phases. This time I related to the vessel because there is no drag actually. And then we have the same parameter, power delivered, fuel consumption, liter per hour. You can see how different are the two different fisheries. This is very colorful table, but we played with the indicators and we gave a rank. Just focus on this column here and this column here. So higher it is, this value, better is the profile. because actually F, G, E stay at the ratio, the denominator in the ratio. So higher it is, better it is. And the color is based on the association of these two ranks. This rank during sailing, and this is fishing. For example, the better situation is this one, because it has 3 and 1. So it is followed by this 1 and 4, and 2 and 3. So if you sum this 1 and 4, it gives 5. This gives 4. It's very simple in the classification. So the worst was this PTM 3. Was very expensive. And with this analysis can give an indication of the fisherman how he is working. We thought that vessel monitored were not so efficient, because mainly because of the outdated technology used. These are for the Italian situation. There is a kind of barrier. They are very traditional, and they are it's very difficult to improve their technology. And this caused an energy consumption very high. This is a positive and negative at the same time, because there is space enough for improving. But they need a check before for measuring how the energy is used. And in fact, this protocol we develop can give a potential area of improvement very clearly. As regard the first experiment where we tested and where we measured the vessel during their commercial activity, we found that the vessel with a fixed pitch propeller was more expensive than the other with a controllable pitch propeller. Because in fact, with a controllable pitch propeller, you can adapt the propeller to the operation. If you are in fishing, if you are in steaming, you just adapt the propeller, and fixed propeller cannot. And another trivial information, but actually can give useful information, is that during a steaming condition, when you are close to 10.5, there is an incredible increasing of consumption just with a 0.5 knot of increment. Is that necessary? So we saw that after we installed this system, they reduced from 11 to 10.5. There was, as I said, a behavioral effect. Yes, hydraulic and electric users were not so expensive, actually, at least in the monitored vessel. So maybe in 5 minutes, I'll show you also this potential improvement. We tested the new design during the last year, and we passed from traditional otterboard to semi-pelagic otterboard. I'm going to present the comparison between these two, traditional against a semi-pelagic. So we usually install a sensor on the doors and on the vessel for measuring the distance, otterboard distance, and net opening. Very important also for semi-pelagic or vertical door are the information given by the pitch and roll sensor. And these are the comparison between the two doors. So you have a trolling speed in all the graphs and the fuel consumption rate. And this is the opening, horizontal net opening. and horizontal door spread. Focus on this and this last one. So the experimental, well, not experimental because it's commercial actually in the North Europe. The semi-pelagic door is less expensive in terms of fuel consumption than the other. And at the same time, it gives a bigger opening. This is the comparison between the traditional and the semi-pelagic. This is trawling speed and the door spread, net opening, vertical net opening, fuel consumption ratio. And so have a look. There is a difference of 10%. And if you base this difference, 10 liter, 18% between the two configuration, traditional against the experimental. So 80% in fuel consumption. You have a 58 liter against 48. The same result have been found by other institute with this semi-pelagic. And as regard the catch, we tested these doors during a couple of cruises, and we didn't find any difference, any significant difference. I divided the catch in commercial, debris, and discards, and you can find kilogram per hour. This is the most important part, actually, is more or less 13 against 12, but was not significant at all. And then, you see, there's no significance. And then we also found, on the other way, with this configuration, we also caught less species that are which are discarded. And, but also in this case, it was not significant. I'm not an economist, but I try to, I'm not sure that you can read the number, but anyway, I try to figure out a situation and give try to make an analysis, an economic analysis. So you have all the day in a week. They fish 3.5 days per week. They stop during the weekend and the Friday they stop. So you have 53 hours per week, which in total yearly, considering all the holiday, etc., you have 2,491 hours, more or less. So the profile, if you consider then you have 168 hours per week, and per year you have, as I said, 2,491. The fuel cost when the experiment was carried out was 0.6. Now is even worse, is 0.75 in Italy. And then the situation, the economic analysis will have been even better in terms of saving, of course. So the door investment, the experimental door cost double of the traditional. And so there is an extra investment of 3,500. And considering this profile, per year you would have had 70,000 euro of cost, fuel cost, against 57 using in the configuration the experimental. So you have per year you have a saving of 12,000, which give a payback time of this extra experiment of around 3 months. These are the conclusions from this experiment. The horizontal opening was even better, And the fuel saving with the experimental, well, with the semi-pelagic, outerboard was around 18%. And as I said, this extra investment of 3,500 would have been covered just in 3 months, considering the saving you have. 3 or 4 months actually, considering that catch was pretty the same. So that's it from my side, and thank you very much for the attention.